Okay, hi guys. So in this lecture, we'll be seeing about electrophile, nucleophile, some of their examples. Okay, so let me start first with electrophile. Oops, yeah, electrophile. Okay, so what's an electrophile? Electrophile, as the name suggests, it's just electron loving. Electron loving. So which compound can actually be electron loving? Which that is positively charged? Okay, so let us take some examples. This is R plus, Br plus, Na plus, uh, NO2 plus, NO, or this one. So their name would be, just add neum against their names. Okay, so this would be carbonium ion. This would be bromonium. This would be nitronium. This would be nitrosonium. And this would be diazonium. Okay, so Lewis acids are actually electrophiles. So let me take some examples of Lewis acids and why they are electrophiles. Okay, so if you take examples of AlCl3, then you can actually see that Al has empty d orbital, so it can accept a pair of electrons in its d orbital, hence it's a electrophile. Bf3, same for Bf3, it has a empty p orbital. Same for Zncl2 and FeCl3. So for now, if you don't remember or don't know the hybridization of Fe or Zn, just leave it for now, and we'll see that part when we talk about the configuration in our inorganic lectures. Okay, so what else are the examples of electrophiles? So this was the example of charge electrophiles. Okay, the second category came to Lewis acids. Now we'll have something like interhalogens are electrophiles. Now what are interhalogens? You'll just get to know in few seconds. Interhalogens are electrophiles. Okay, what are interhalogens? These compounds are interhalogens. Okay, and why are they actually electrophiles? Because you know this is the order of halogen family, and this is the order of electronegativity. Fluorine is the most and iodine is the least electronegative. Okay, so in terms of electronegativity, iodine has a partial positive charge and chlorine has a partial negative charge. Similarly for bromine has a partial positive charge and a chlorine has a partial negative charge. So the presence of electronegative difference creates a partial positive and negative charges within the compound, hence they become electrophiles. Okay, one more example or one more category of electrophiles are oxides. So oxides are electrophiles. Okay, now what are oxides? Oxides are, if you take the example of CO2, then actually carbon atom has a partial positive charge over itself. If you look at SO3 gas, then sulfur atom has a partial positive charge over itself. Other examples can be aldehyde ketone are electrophiles. Why? Because the carbon atom nearer to the double bonded oxygen atom is partially positively charged, hence they are electrophiles. Okay. Vacant orbital of lower energy level are electrophiles. One more category is vacant orbital of lower energy levels or electrophiles. Okay, so this completes our section on electrophile. Now we'll be looking into nucleophiles. Okay, so what are nucleophiles? As the name suggests, nucleophiles are nucleus loving compounds or groups or atoms, so they are nucleus loving. Okay, so what are the categories of nucleophiles or examples of nucleophiles? These are charged nucleophiles, by charged nucleophiles I mean OH minus or NH2 minus, or it can be RO minus, where R can be CS3 or C2H5 or phenyl ring. So this is called alkoxide. So similarly this would be methoxide, this would be ethoxide, this would be phenoxide. Okay, now let's take a look at neutral nucleophiles. So what are neutral nucleophiles? If we take some compounds like H2O with lone pair on oxygen, obviously, if we take examples of ammonia or alcohol or RSH, so these are neutral nucleophiles. Okay, if we take example of simple alkene, so the p orbital actually has a double bond between itself. Or if we talk about alkyne or a benzene ring, then we can say that these, so why are they actually nucleophiles? They are nucleophiles because they can give their pi electrons, give their pi electrons, hence they are nucleophiles. Okay, so nucleophile must have a lone pair or pi electron cloud or negative charge or something like that for it to be termed as a nucleophile. Okay, so nucleophile must have lone pair or pi electron or negative charge. Okay, so in the next lecture we'll be looking at the types of reaction, addition, substitution, elimination, rearrangement, and we'll be taking some of the examples on the same. So till then, good luck and goodbye.